Thanks so much for all the kind words. So the honor is really on my side to be, virtually present. Thanks so much for the very kind words, and it was a huge pleasure to meet you. And I think we do have a lot of research interest in common. So I hope to, that maybe there is some follow-up at some point, that we can learn from each other here. And let's see. So thanks a lot for this invitation. So, all right. Today, in fact, I will touch up on this question of what I call human labor variation and whether it's really so bad for AI. And in this talk, I will essentially, my idea is to give you a lot of, a broader perspective, hopefully, on this problem, which I think is really important to tackle in future and has been worked on, and I'm trying to bring some of these ideas here together, and hopefully stipulates also some of you to look more into this in future. All right, then let's get started, and please interrupt me any moment. I can see the webinar chat, but that's only I don't see that. So maybe if there are questions, you can from the panelists and just let me know, or we do it at the end. I'm fine with both ways. Yeah. All right, then today what I want to focus on is this problem, human labor variation. And if we take a typical, AI pipeline, then how does this conceptually look like? Well, we are often interested in modeling some phenomena from data. And here is just an example of, say, we get annotated data for path-to-speech tagging, one of the core NLP tasks. And once we have the data, then we want to model it and want to estimate want to learn the phenomena, but then another and the third important conceptual part in this AI pipeline is evaluation. And why do I bring this up? This is hopefully known for, all of you know this, but I would like to bring this up as a conceptual framework when talking about human labor variation, because it is something that is often considered only at the data annotation stage, but it's a problem that is really affecting all of these types of the steps of the pipeline. And this gives us also kind of a skeleton on how we can look at these different parts in this talk. So this is kind of an outline. And just to motivate the problem, if you look at this example and ask people, hey, how many sticks are there? We can see perhaps that there are at least two different answers that we might get. And this is just to motivate that in many cases, there is not such a clear-cut distinction, right? And so we see that human disagreement is something that when we do annotation projects, which are so fundamental for NLP, for computer vision, for any bigger AI task, we essentially notice that this disagreement in human annotation is everywhere, it's ubiquitous. And here I really want to emphasize that it impacts all three stages of the typical, here in this talk, focusing on NLP pipeline. But it also connects to an important problem which is gaining also more traction, which is modeling of uncertainty. Model uncertainty, human uncertainty, all of these important topics that are becoming more and more important. I believe that's why it's really now also the time that we reconsider this this issue, which has been known by a long time. And so let's. Oops, no, sorry, now move the, apologies for this little hic. So we'd like to, make you think and propose that actually this human disagreement could perhaps be turned into something which is advantageous. Because typically in annotation projects, what we try to do is to maximize agreement between human annotators and refixing the guidelines in order to achieve higher annotation agreement scores. But it's really often not easy, and why don't we look and see it as an advantage? And I call this a sort of fortuitous data. So what do I mean with this? It's a general concept that I like to think of whenever we try to model some phenomena in language, for instance, then often there is additional information outside the main problem available. and we could perhaps make use of this photoreaders data sources. And so it's a little bit like looking at this cube, which changes, you know, accordingly on how you look at it. So it might, if you have a different perspective, you might see something else. So this is kind of illustrative of this concept of photoreaders data. And annotation disagreement is one kind of photoreaders data, which is not so much available, but in technical terms, it's quite close often to the actual problem we're solving. So it's also kind of ready data, in contrast to other sorts of information that could also be photoreaders data sources. And that's, for instance, thinking of more distant data like cognitive behavioral data, like gaze or keystroke. They are less available, but they're perhaps more available, but not readily available or readily usable for tasks. All right, so in this talk, I will focus on annotation disagreement. But before going further, you might have noticed I called the talk differently than disagreement. So I call it, what about human label variation? So in fact, I was thinking about this for a while, and in also early work, we only talked about disagreement, but by looking at the literature, I noticed there's so much variation how people essentially refer to the same kind of concepts, and it might also be stemming from different properties of how the label divergences or variation has been created. And so here I propose to use perhaps this more general term human label variation, because disagreement really implies that there's only two or more views cannot all hold at the same time. And this is also an attempt to reconcile different notions found in the literature. And there's also very happy that a UNLP paper, theme paper, got accepted about this topic. So I will refer to that also here in this talk to give you more details. But essentially, this embraces all these kinds of, we assume that there is some genuine disagreement or variation, and that might stem from different reasons, but all of that are essentially instances of human label variation. And to just be aware or make this distinction, there is also something called annotator errors. And this is, again, right, we'll come back to this. This is related, but sometimes it's really clear that it's an error for some tasks, while for others it's more shaded notion. So, all right, I hope this gives you an overview of where I'm going with this talk. So in the rest, I will focus on these three perspectives, going first into the data part and looking at whether this human label variation is random noise or some signal. And then I will focus and look on modeling. So how can we leverage human label variation, or will provide you an overview of what has been proposed. And then in the last part, we will go into variation in order to touch up on this important aspect as well. All right, then let's look at the data part first. No, sorry. Should I move this? It always goes away. So let's look at the data part. So there is a lot that can be said here, but here I just pick a few examples. So if we think at the part-of-speech tagging, assigning word classes to words, then it's well known that there are cases where even for this kind of more objective NLP task, there are linguistically debatable cases. And in fact, this is also what motivated some of our early work when we were working on this problem. We saw that by annotation, we observed plausible disagreements in annotation, like, for instance, here is an example of social media case. What is social in this noun-noun compounds? A lot of work in this direction also stems from other related work by, for instance, Laura Ioro and Chris Welfy, and they looked at medical relation extraction amongst others. So if we have here this example and ask crowdsourcers to give their relations, you see here an example of where there's really a lot of variation of plausible disagreement, right, associated with or causes, prevents, some, yeah, just to give another example. We can go further, and we also find papers that discuss variation in terms of syntactic variation. Here is an example where both the upper tree and the lower the tree shown below show you two possible dependency relations. And so much more work has been recently actually done in this area on the NLI task. So here the problem is you have a premise and you have a hypothesis, and you are interested whether the premise entails the hypothesis. This is a task that has been, has been known better as recognizing textual entailments in early days. Nowadays, it's mostly referred to as natural language inference. And there was this nice study which essentially re-annotated an existing data set, a subset of an existing data set, and then they looked at the distribution of the annotation. So you see here contradiction, neutral, and entailment are like the three categories. And they saw that there is, not everything just entailment. There was also a large portion of annotators thinking it's neutral or contradiction in this case. And I will come back to this essentially later on again. In fact, also Sissi, I was really, really happy to find her paper, which was unknown to me for a long time. But also in Sissi Alm's work, she really was one of the early people mentioning this problem, especially if you think of subjective NLTP tasks like affective meaning or emotion recognition and so on, just as an example. So making this point as, hey, maybe for these tasks, there is really she called an absence of real ground truth, right? And also pointing out the challenges with the traditional notions of inter-annotator agreement, and even also evaluation was already mentioned there. And now the list of examples that we can find is actually growing. So perhaps you notice also that some of the references are more recent. In fact, we can observe there's a lot of interest in this now emerging in recent years on abusive, offensive language detection problems. But it doesn't stop there. There's also some people interested now in problems that are between language and vision. So for instance, in vision question answering, there's a nice recent study by Jolly et al. And what they looked at is whether they can actually try to find instances where like here, where is this picture? This is a not so easy example to annotate. So they try to essentially look at these answers where normally it would be just one ground truth. So you would just model rho to see the right answer, but neglect all the other options. So let's see, now we saw a couple of handpicked examples. Is human label variation something which is just randomly distributed? Or can we essentially estimate these disagreements from small samples of multiple or doubly annotated data? And this is early work that we have been doing, 2013. So back then, in fact, we looked at part of speech tagging. So what you see here is the tag set with 12 tags used back then in the study. And we see a confusion matrix between the tags, between two annotators. And we see them over two different text types. So on the left hand, the Wall Street Journal, on the right hand, a sample on Twitter data. By looking at this, there is like a shade that's coming back, but there are some disagreements that are essentially that we found to be rather consistent across domains, at least in these two. So like apposition nouns were quite frequent, or particle apposition, adjective nouns or particle apposition cases. So it looks like there is some systematicity here over those different text types. But of course, there's also variation that is more specific to certain text types. Like here, we saw these examples with these catch-all and the numeric interpretations. So we can say it does at least look like human label variation is not just randomly distributed. There is some systematicity to it, and then can be estimated from small samples. And yes, we can do so because we can take, for instance, these confusion matrices. Now the questions can be, what can we do with them, right? Would they help us essentially make our model more robust, for instance? Another question related to that is human label variation a unimodal distribution? Because does it contain more inherent variation? And what I mean with this is typically we would think of, you know, an annotation task as we want to model the single ground truth, the single label that relates to this instance. And that means essentially that we would assume also a unimodal distribution behind it. And there is this nice work by Eli Pavlik and Tom Kwiatkowski from 2019, which essentially questions this by doing these re-annotations of the natural language inference data. So what they did is, this was this example that I've shown you earlier as well, but just to go a little bit more in detail here, for instance, we have on the right premise, Paula swatted the fly, and the hypothesis that swatting happened in a forceful manner. We see that there is, if we were to model it with a Gaussian mixture model with just a unimodal distribution, this was one component, that would fit the data less than, say, this bimodal distribution that they found here in this data. So they essentially re-annotated that on this scale. So not categories, but they used this -1 to what was it? 1.5 -1 to 1. Sorry, -1 to 1, and then found that a model that essentially is a Gaussian mixture with multiple components is explaining the data better. In fact, they found this on around 20% of the data. That the two, you see this here with the orange component, where you see that there is a quite substantial amount of data that is better explained in this way. So is human liberation than unimodal? No, it looks like it's not the case, right? So we can really think of this, hey, what then is about our single ground truth assumption that is so present in still all of NLP today, because we essentially see in studies like the ones before that there is inherent variation, but we're essentially neglecting it most of the time. So I would put forward that this human liberation is really signal, but you know, you could say, okay, let's pause for a minute. What's the origin of this variation? And of course, this is a very good question to ask. We can think of, okay, sometimes it's really the stimulus itself, which, you know, depending on the level of ambiguity or maybe even the task difficulty, we see more or less variation. But more and more, it is becoming also important to think about individual preferences. So also the preferences that, you know, when we ask our annotators, they come with their own backgrounds, and it's becoming more and more important to also, you know, include these kind of variations, because in the end, our technology is also becoming much closer to the real end user, so it's becoming much important to look at the data in more detail. Another, in fact, issue of variation is attention. So there can be also attention slips. So some of it might even then lead to annotation errors. But there is even an ongoing, I will come back to this as well, what is an annotation error and what is plausible variation. It's a huge underlying question that also needs more work in future. A recent work and study that I can point you to, which is really nice, is the one by Yang and de Monef. So there's an upcoming TACL paper, and they essentially examined this NLI task in more detail and came up with a linguistically motivated taxonomy of why, you know, there might be differences in disagreements or differences between human annotators. So I think we really need more work in all of these directions to understand what are the sources of this human label variation for future models. All right, this ends this part on data. Now, I hopefully have convinced you that there is a lot of variation out there. And the next part will show, or will ask, okay, if we assume this human label variation is signal, what has been done so far? What were the approaches taken? Right. So what can we do in the modeling part? I try now to outline a kind of a taxonomy of bigger research strands or views on this. And so, in fact, a big research strand traditionally has focused on aggregation of filtering. And we have here again a set of aggregation methods or filtering methods. And the opposite, or the kind of other direction is, hey, what about embracing this sort of variation? And then there are two big strands that we can find in there. One is to learn from the unaggregated labels, and the other one is to try to enrich ground truth. So still assume that there is one ground truth that we are modeling, but enrich it with the variation well. And I will get into each of these methods next, so to give you an example for each of them. So aggregation is the typical setup where we have, say, a set of documents and, say, 3 annotators, and we ask them all to give their labels. And now aggregation is the typical setup where we have derived and this gold label by majority vote or other aggregation methods. And then we use only the gold truth to learn from. So we learn from these aggregated labels. And that's really the most widely adopted methodology today, but it has this one big problem or issue, that it allows only one label or one belief or view to propagate to the model. Now, instead of doing aggregation, there's also some other line which proposes filtering of data. So the idea here is similar. So you ask multiple annotators and then derive a gold label, but you additionally try to filter out cases where there is really high disagreement or high label variation. So this is an approach that tries to, filter out instances which are too noisy to learn from. So it's still aggregated labels, but filtered instances that are then taken into consideration and modeling, and it's essentially wasting data and also again neglecting these human nuances. All right, now instead of filtering or aggregating, what happens on what about embracing this variation? And so one method that you could try is, in fact, what about just directly modeling, learning from the unaggregated labels? In fact, this is gaining increased attention, not just in the NLP community. There is also work in the computer vision community. It's not a new problem again. There has been studies which go back to 2008 and 10 approximately, maybe even earlier. And there is a lot of methods that have been proposed in this sphere, but they range really from multi-label methods to architecture-specific choices that you can take, or simply take the labels as a distribution along the distribution instead of the categorical label. So far, what we did see, though, is when in a recent survey with Alexandra Uma at collaborators, this was a big effort. We tried to re-implement, or she tried to re-implement a lot of these methods. She saw that overall, we could see that learning from this unaggregated data directly was not yet so successful, at least for NLP tasks. So the question is why essentially, and how can we go beyond it in future? I think this is promising, but not yet ripe ripe enough. Instead, where we see more promising result as of now is to enrich the gold label with distributions. And here again, the key idea is now you essentially take both into consideration. So you still derive gold label and then learn from both aggregated and raw labels. And here, this is in a way embracing these nuances, and you can think of it, in fact, as kind of a regularization effect, because you do, try to learn a model that learns the gold distribution, the gold label, but is enriched, right, with this distribution around it. Now, again, there's many different ways to do so, but we just point out a couple of directions. One was, in fact, you could think of enriching the gold label by the confusion of the annotators, right? If you have a small sample, you can estimate these kind of global confusions. You could then update less on labels which get also confused by humans. So that's the key idea of this model. But there's other work, and more recently people have explored multitask learning in the sphere. Our work, for instance, has proposed to in fact use a soft label multitask learning objective. So what was in the left, you see the typical neural network that gives you an output, and then you see the gold label, and then you just back propagate with the single gold label, right? And here instead we proposed to do the same essentially, but enrich it with the distribution of the human annotation. So you try to not only match the gold label, but also at the same time learn this regularize so that looks, hey, don't go too far away from multiple human annotations or the human distribution. And so this is one of the multitask learning options. This is not the only one, and this I want to highlight. We are not the first to propose to use multitask learning for learning with human label variation, but it's one kind of instantiation of this idea, and it just needs one auxiliary hat instead of others who have proposed essentially to model each individual annotator, right? If you have individual annotators, you can, instead of seeing it as distribution, model it differently. And we saw quite good results with these methods across the board in the survey paper. In fact, here's what the result looked like. Here's the single task learning model for part-of-speech tagging and stemming, which we used in the paper. And we can see that the MTL model was outperforming the single task model, so it's beneficial for both of these tasks. All right, now let me show you another example. So we heard now we can essentially enrich the gold label with these distributions, but what about learning from unintegrated labels directly? There's an approach called deep learning from crowds, and here the idea is that you essentially learn each annotator's annotation separately in a kind of a multitask learning model again. And we proposed that with yeah, I have to say these are, you see them in the picture. These were bachelor students at ITU, really great. They were doing their thesis project, and we focused on this problem here on understanding indirect answers to polar questions. We created a data set for this problem. So the problem is here, you have a polar question like, hey, everything okay? And you have, you know, a human who just says, I'm just mad at my agent. And this is very easy for us humans, but a very tricky problem, pragmatic problem for a computer. So the task is to try to categorize it along these lines. So what is it? Is it yes? Is it no? And in fact, you can see that there is, again, this is not such an easy, clear-cut task. So we've observed on this data set around almost 6,000 question-answer pairs that on 25% of the data there was a disagreement between at least 2 of the 3 annotators. And so what we saw then, in fact, is since the data is annotated with these 3 annotators all along, so also def and test splits, we could look at the model predictions and look at what happens if all the, you know, if all the annotators agree on a label versus if at least 2 agreements. And what we found is, in fact, the model is challenged more or has more incorrect predictions when also human annotators did not agree on a ground truth. So notice we still model one ground truth here in this one, but we tried then to also leverage this crowd layer idea. And what we saw is that, okay, while we are able to capture the individual confusion matrices of the annotators and improving the F-score slightly in this problem, it wasn't yet, you know, improving the model's accuracy because it didn't equally improve over all of these classes, which are also skewed. So there's more to be done in this sphere. It was just proof of concept, essentially, and the creation of this data set. So for more methods, overview, and evaluations, there is this JIR survey that I can point you to for further information. And I just browsed over some of the things we have been working on so far. All right, but let me give you, you know, now I've shown you a couple of selected cases of methods that we use to kind of directly or indirectly learn from human label variation. I would like to point out to 2 other studies that I think are really connected, but not so directly than the other works. So there is this very nice talk by Swapna at ACL, Rising Star Talk, and they have proposed something called data maps. And data maps, if you haven't heard of this, is a very neat idea of essentially looking at how does the model, you look at during model training, how the confidence and the variability in the confidence varies over training epochs. And so you can then look at whether this shape, this croissant shape here gives you a sense of, okay, these are very hard instances, or very, they are not correct, and the model is very unsure, and they are also very low variability, but then you can find the easy cases on the other hand, and there's a lot of cases where the model has a hard time to figure out what's the label in this case. What they showed is in these data maps, you can identify the subsets of the data the model has. They are ambiguous instances. And what they did then is to look at, hey, what if we train on a subset of the data, which is, here you have the original and then a random subset and only a subset, which is the ambiguous part. So you take this kind of set here, and what they found is in distribution performance was essentially very similar in these 2 cases, where you only take 1/3 of the data to the original model. But what was striking is that in out of distribution performance, the model that's trained on the ambiguous cases was actually performing better, which tells us that these cases can actually help us in out of distribution generalization. Right. So we took inspiration from these data maps. My PhD student Mike was working on active learning when he started, and we were interested, hey, can we use this kind of information also to derive another, active learning? You query the data to ask which instances you give to the model, to the human to annotate. We then looked at, hey, can we actually use this distinction or this boundary between hard to learn and ambiguous cases? And we found some promising results by using what we call cartography active learning. So exploiting this kind of behavior for a new acquisition function. All right. Now, this hopefully gives you some, overview of what's been happening. Perhaps I should say it's necessarily incomplete. So if you know any more works in this direction, please also let me know. I'm very happy to hear more. Also from, HCI community. I think there's a lot of related work I might not be aware of. But what's really great to see is there is really increasing interest in the NLP community. Yet at the same time, it's still also quite fragmented. We see very sub areas being studied more and in isolation. So I think there's a lot to be gained by looking at this in a more global scale. There's also, though, a lack of diverse data sets, although we have first traces of evidence that even if you have small annotation, small samples of doubly annotated data, that can be useful, and it connects to a lot of other different interesting problems, like what if you have data which is labeled to different amounts of labels, and so on. And as I mentioned, there's for sure a lot of other connections to other related disciplines, which is yet to be explored in future. All right, this ends the second part of my talk, and I'm moving to the last part on evaluation. So this is a big question, and this is really work in progress. So we published this position paper last year in a workshop. We need to talk about disagreement in evaluation because there are quite many works on trying to learn from disagreement or human level variation, but then when it comes to evaluation, they still assume that there is a single ground truth. This includes our own work as well. So what this means, in fact, we are essentially, focusing on easy evaluation, right? But we have seen also work by, for instance, Gordon et al. That these metrics that we often tend to use, sometimes even single metrics, they often are not aligned with reality and how the system then behaves when you really do human relation studies. Recently, there has been, though, a shift in looking at beyond just one evaluation metrics or one hard evaluation where you assume still a single ground truth. And there is some work on using also what's called soft labels for evaluation. So just a few examples on this. The study by Davani et al. That came out of TACL last year, they also, besides the traditional GOAT evaluation, looked at individual F-score differences of annotators. Then there is a line of work that looks at finding clusters of users, especially in the more in the hate speech community and so on. Related to this, there is also something proposed, disagreement deconvolution. They again propose a similar idea where you try to model each annotator, but still find similar-minded annotators. So you do also clustering, but in there they also have a model where they try to estimate the primary label of a single annotator. And in fact, this whole evaluation also is connected to uncertainty, and I will come back to that essentially in the second part as well, but in some parts soon as well. All right, so is this human behavior so bad? I do not think so, and I think actually this is a huge opportunity we have now, because we need more trustworthy and also more human-facing AI. So I think really now is the time to look into this. So I would like to point out to ways forward, or what could you do, what do we need in the future? So one is certainly more data sets to collect and release more on a data level, unaggregated data. This has been also put forward by others. And but in general, I would like to highlight I'm really a strong advocate for releasing any other kind of metadata as well, because this could help modeling. Also, if you don't think of it right now, it can help someone else down the line, or just also help make sense of the data, like whatever time or annotator information or genre labels or whatever you can additionally, or how you sampled the data exactly, all this kind of information can be very, very valuable. In fact, I'm happy to see that there is a little study where I looked at the NLP ACL ontology, which is the main resource for publications in our field, and we do see that there is more and more data sets becoming available with unintegrated or multiple annotation information. And so I'm very happy to point you, in fact, to this very recently, actually it's available as of today, repository. So if you know of any resource which is missing, please let me know, please contribute, please spread the word that anyone is welcome to contribute if they know more data sets that could be of interest here. Another point which is important is evaluation, and in fact, beyond accuracy or single mode evaluation. This also connects to, typically we are only evaluating the labels and not so much the confidence of the classifier or the model uncertainty. And there's really interesting connections here. And here's a paper from TACL, Davani et al., that they proposed another multitask layer model, where they also essentially model each individual annotator. And what they did, what you see here is essentially they correlate the output of the last three here are all models that essentially embrace the annotator human label relation versus taking models that just take a single ground truth into consideration. They show that there is a higher Pearson correlation with the human label distribution if you in fact model it also, right? Makes total sense. But there's been so much work in looking at in this direction so far. And just a small example that we looked at recently is also calibration in model confidence. So when you talk about model confidence in the neural network literature, it's very well known that they are not so good at not knowing when they don't know. Essentially, that a model is, if the model would know, if the confidence is low, then it would not be correct, and vice versa. This is something we would ideally have a model, but they are really, really often overconfident, or simply said, miscalibrated. So there is in the machine learning literature, a lot of work in this direction, and also proposed way on how can we actually measure how calibrated a classifier is. And one of the early and also most widespread ways today is the expected calibration error, where you look at the accuracy and the confidence over the bins of, over the confidence bins of the classifier to estimate an expected calibration error. To understand this, we can look at this reliability diagram. So you here see the model confidence between 0 and 1. So you bucket them and then look at, hey, if the model is 90% or more correct, you would expect it on average that it would be also, if it's 90% confident on average, you would expect the accuracy of the model also to be 90%. If it's not the case, then we see that it's under calibrated, while here, for some reason, it's even much low confidence, but it's really right in this case. Okay? So ideally, all of these bars would be close to the diagonal, and we would have a very calibrated model. And we looked at this from a ground truth perspective, because this calibration evaluates against accuracy, which assumes there is one ground truth. And so Joris looked at this on this NLI data set, and we got recently, we're very happy to announce that we got this paper accepted at the MLP, where we look at this problem, and what we find is that the kind of taking calibration as it is and applying it to data with human disagreement is problematic. And just to give you some outlook on the findings, we have seen now the model here. This is this reliability diagram, right? And there's a range of methods you can apply to make it more, calibrated, like temperature scaling. So then you can reduce this score from, say, 14 to 3. But what does it then mean? It's very hard, to get the feeling about this score, and it doesn't tell you very much, right? You think, okay, it's better calibrated. But we cannot look at the individual instances here because we're measuring global accuracy. So instead, we propose to look at the instances and look at the human label variations in order to get a more insightful view on this global variation of calibration. And that's what we did in this paper. So we measure essentially the divergence between individual confidences and human label distributions. And what we found is how this is the model that is this one here, that's better calibrated. There are some, let me just give it. What we do if we, here is the temperature scaled model. If we do this in contrast to the vanilla model, we get fewer extremely miscalibrated instances, also seen here by this drop, right? But what we do observe as well is that we also actually miss on the instances which were very well calibrated in the beginning. So we are actually making also quite some mistakes on that side. So it's perhaps not such an optimal solution that which would hide under this plot here. And in the paper, there's more. This is just a small outlook on what we have been doing. And hopefully this inspired some of you to also go and see this paper or ask me if you are interested here to hear more. So the last point, in fact, relates then to learning, and there is a lot of more to be done in this area. I hope, I convinced you that there is really a range of human label variation. We have seen some examples in the beginning. Then we looked at also some methods that have been proposed, and then some directions of variation. But I think it's also very important to think of this label variations, this continuum, where we do have noise as well. In most of the talk, I assumed that the labels were genuine and not just noise, but there is also not so much work yet in detecting noise and so on. But hopefully, if we in future go more towards modeling human label variation, perhaps we can even get more informative samples, more rich samples, and learn from fewer samples. That's an open question. All in all, the human label variation is not all of it is noise, and we can learn to embrace it. Let's not continue, with the way of just modeling this one ground truth, but try to think of ways on how we can embrace this variation. Embrace it also in a variation. There is a lot of research opportunities in this space. And if you're interested also, that we have a semi-voucher task running for next year. So now you can get the training data. The evaluation is happening in January, where is a potential to contribute, to which I invite you all. Here's a couple of selected talks, also the one with the repository, with the survey, and the recent paper on calibration that I mentioned. And yeah, this brings me to the end of the talk, and I'm very much looking forward to discuss with you, and close now my screen to hopefully see a couple of you here. Let me stop sharing, and I look forward to your questions.
All right, so you can turn off the recording, please.